We are going to see some of the problems from the chapter hydrocarbons. Some 4 compounds are given. Compound A, 2-methyl butane, 2-methyl butane. B, 2-methyl propane. C, 2,2-dimethyl 2,2-dimethyl propane. D, N-pentane. 4 compounds are given, and we have to identify that compound with the lowest boiling point. In the case of hydrocarbons, boiling point increases with molar mass. When molar mass increases, boiling point increases. Suppose compounds of same molar mass are given, then boiling point decreases with branching. When more branching is present, the boiling point decreases. Now look at this compound, 2-methyl pentane. You try to write the molecular formula or the structural formula of 2-methyl butane, 4 carbons. In the second carbon, a methyl group is attached. So it is CH3, CH3, CH, CH2, CH3. So the molecular formula is C4H367 The second compound is 2-methyl propane. C. Propane is the parent hydrocarbon. In the second carbon, methyl group is attached. So it is CH3, CH3, H. So its molecular formula is C4, C4, 9, 10, CH3, 9, 10, C4H10. Here it is CH3, CH3, 3, 6, 7, 9, 12, C4, 1, 2, 3, 3, C5H12, C4H10. In this case, dimethyl propane. So CH3, C, CH3. Dimethyl means in the second carbon, 2 methyl groups are attached. So totally C5H12. And in the last one is a straight line. This is a linear compound. CH3, CH2, 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 CH3, N-pentane. So its molecular formula is again C5H12. So when molar mass increases, boiling point increases. Therefore, the boiling points of these compounds are high. So the only compound with less molar mass is this. So this is the answer. Suppose if this answer is not given, then that compound with more branching will have the least boiling point. So here the branching is more. Here no branching at all. And here only one branching. But in this compound, two branchings are there. Therefore, two things we have to compare. Number one is the molar mass. Number two is the branching. But when such problems are given, immediately you have to first draw the structural formula and then you have to see how many branchings are there. And also you have to write the molecular formula also to know the molar mass of the compound. Look at the reaction. Bromine reacts in the presence of light. Then the major product will be, what is the major product of this reaction? You have to identify the major product. Four products are given. In the first one, the hydrogen in the branching is replaced by bromine. And in the second option given, bromine goes to the next carbon. Here is the substitution already. The bromine is getting attached in this position. In the third option, CH3 is there. Already one more hydrogen is here because this carbon has 4 bonds. The carbon is attached to this carbon, and this carbon. One hydrogen is there. That hydrogen is replaced by bromine. And the option 4 is bromine is substituted in this carbon. Now, which is the major product? When the reaction, halogenation reaction is taking place in the presence of light, free radical mechanism will take place. According to the stability of the free radical, this will be the major product. So, in the presence of light, H nu means light energy of suitable frequency, which will make the bromine undergo homolytic division to make bromine dot and bromine dot. So when this bromine dot is getting attached to here, the formed free radical will be more stable. Therefore, this product is the major one. Which of the following isomeric heptanes? Number of isomeric heptanes are given. Heptanes, 7. Compounds with 7 carbon atoms. Which of the following isomeric heptanes can yield 7 different, watch closely the question, 7 different monochlorinated products? 7 different monochlorinated product. 7 different monochlorinated product upon free radical chlorination. Free radical chlorination. First of all, you have to understand the question. Some 4 isomeric heptanes are given. A, 2,2-dimethyl pentane. So dimethyl 2 carbons, pentane 5 carbons, totally 7. So it is a heptane. 2,2-dimethyl pentane, 2-methyl hexane. 2-methyl hexane. Hexane has 6 carbons and methyl has 1 carbon, so totally 7. And the next option is 3-methyl hexane. It is also hexane, but the methyl group is attached in the third position. And the next compound is 2,4-dimethyl pentane. 2,4-dimethyl pentane. So all are isomeric. All are hydrocarbons and all are alkanes and all are having 7 carbons. Among them, one hydrocarbon is able to produce 7 different monochlorine substituted compound. We have to identify that. Whenever such questions are given, immediately you should write the structural formula. See the first one, it is a pentane. So carbon. So carbon, 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 carbon. 5 carbons are there. In the second position, 2 methyl groups are attached. So this is 2,2 CH2, CH2, CH3. So 2,2-dimethyl pentane is this. And in the second one, 2-methyl hexane. 1, 2, 3, 4, 5, 6. Second position, methyl group is attached. So this is 2-methyl hexane. Third compound is CH3, CH2, CH2, CH3, CH2, CH3. 1, 2, 3, 4, 5, 6, 7. And the fourth one, 2,4-dimethyl pentane. 1, 2, 3, 4, 5. In 2 position, a methyl group. 3 in 4th position, a methyl group. Then you have to balance CH2, CH, CH3. You look here, if this chlorine is replaced, or this chlorine is replaced, all the 3 methyl group on the replacement of a hydrogen by the chlorine, all the 3 products will be the same, and this will be the 4th one, and this will be the 5th one, this will be the 6th one. So this can produce 1, 2, 3, 4 types of monochlorinated hydrocarbon. Here, whether the hydrogen is replaced from here or here, it is going to be the same product. So 1, 2, 3, 4, 5, 6. 6 types are possible. But look here, this is one type. This is second. This is third. This is fourth. This is fifth. This is sixth. This is seventh. So only this compound, all the 7 hydrogens in the 7 carbons are non-equivalent. But in all other compounds, there are equivalent hydrogens. So the 3-methyl hexane, it has 7 different types of hydrogens. That means their chemical environment is different. So their replacement will give you the 7 different monochlorinated free radical substances. Or this isomer is able to give 7 different monochlorinated products. Here, this methyl group, they are equivalent. This methyl group, they are equivalent. This chlorine, this hydrogen, they are equivalent. This hydrogen is different. Therefore, totally for one type, two type, only 3 types of chlorinated products are possible here. Here, 7 types of chlorinated products possible. Here, 6 types. Here, 5 types. So, 7 type is possible only in the case of 3-methyl hexane. This question is a bigger one. During halogenation of alkenes, we have to take down the question. During the halogenation of alkenes, the halogens and alkanes show a specific trend, which means that when you change the halogens, fluorine, chlorine, bromine, iodine, then the reaction trend is different. And also when you change the alkanes, the reaction trend is different. Therefore, they show some specific trend. Then, which of the following statement is not correct? Which of the following statement is not correct? So, first statement, the reactivity of halogens is in the order fluorine is the greatest, chlorine next to that, bromine next to that, and then iodine. This is the first statement. Second statement, for a given halogen, the reactivity of the hydrocarbon is in the order tertiary, the highest order, secondary, and then primary. That is the reactivity. Tertiary hydrocarbon will be the fastest one. Next to that, the secondary, and the least one is the primary. And then the third one, bromine is less reactive. Bromine is less reactive than chlorine. Bromine is less reactive than chlorine towards a particular alkane. If the same alkane is taken and bromine is allowed to react and chlorine is allowed to react, then bromine is found to be less reactive than chlorine. And the fourth option, on chlorination, monosubstituted product is formed, while on bromination, disubstituted products are formed. So if you take chlorine, you are getting a monosubstituted product, which means only one hydrogen is replaced, monosubstituted product. If you take bromine, a disubstituted product is formed. So these are all the 4 different statements given, and we have to identify the one which is wrong. So the wrong statement is this one. The 4th statement is wrong because halogenation of alkenes, option A, the order is correct. Fluorine is the most reactive one, and next to that chlorine, and then bromine, and finally iodine. And the second statement is also correct because the tertiary alkanes, they react much faster. The reactivity is very high for halogenation. And less than that is the secondary compound. And the least reactive one is the primary compound. So that statement is also correct. And if you compare chlorine and bromine, what is there in the first statement is getting repeated in the third statement. Bromine is found to be less reactive than chlorine. That is also true for the same alkane. Why the third statement is given like this? Bromine is found to be less reactive than chlorine for the same alkane, which means that if you change some tertiary alkane and if you make bromination and a primary alkane and if you do bromination, so chlorination, bromination for tertiary and primary respectively, if you change, then you cannot say the reaction or the reactivity order will be like this. So you have to take one single alkane and then you have to brominate and chlorinate and you have to compare the kinetics. Then bromine is less reactive than chlorine. So that statement is also correct. But whether it is chlorination or bromination or fluorination, whatever it may be, the halogenation means mostly monosubstituted products are obtained. So the chlorine undergoes or chlorine gives a monosubstituted product and the bromine gives disubstituted product. That is a wrong statement. So the answer is D. This question is something similar to the previous one what we have seen. 4 hydrocarbons are given. Neopentane, B, N-hexane, C, 2-methylpentane, D, 3-methylpentane. The question is, which one among the following gives only one monochloro derivative? You have to watch carefully. Which one among them will give you only one monochloro derivative? First, you have to write the structural formula. Neopentane is this. N-hexane, it is a straight line compound.